Good morning to everyone. This is a classes from Excellence NEET Academy, Bangalore. Dear students in organic chemistry, each and everyone will be having the basic knowledge about how the reactant molecules will be reacted together and it is going to be form a product. Organic reactions are the special reactions in which we are going to learn so many application part which is going to be appeared for KCET, NEET as well as JEE entrance examination. In Excellence NEET Academy, Bangalore, we are all over here to give the maximum benefit for the students, those who are finding very difficulty in their organic chemistry, chemical reactions. We know that in our chemistry, inorganic, physical as well as organic chemistry part is going to become. In that, organic chemistry reactions will be one of the beautiful area and we can learn so many aspects related to organic chemistry just by studying how these chemical reactants, especially carbon compounds in organic chemistry, how it will be reacted with some of the other reactant molecules and it is going to form a product. Let me have a introduction about general principles and techniques present in organic chemistry. Let me start with the topic, the beautiful concept for beautiful minds, those who are happily learning about organic chemistry, chemical reactions. Welcome to our organic chemistry world. General organic chemistry. Here, in organic chemistry, we know about already some of the students, they learned detailed information related to tetravalency of carbon. Let me explain how this tetravalency of carbon is going to be main phenomenon to understand most of the drastic as well as extraordinary chemical reactions that is going to come in our organic chemistry. Tetravalency of carbon. Everyone knows about the atomic number of carbon that becomes equal to 6. When we are writing the electronic configuration for carbon, its electronic configuration is 1s2, 2s2 as well as 2p2. We know that this is the first shell and this is the second shell. The electrons which is present in the second shell, and meanwhile we should also know about in a second shell there will be not a possibility of d orbitals. Most of the students, this concept will be learned in the end of the academic year, but we should know about each and every aspects related to the organic compounds. What and all elements which is coming under first element in a first group, whether it may be a hydrogen and helium, that will be coming under first series of elements, and second one, the second period, right from the lithium to neon, so many elements are going to come. Lithium to neon, what and all elements are going to come? All elements will be having only the second shell. In that second shell, only s orbital as well as a p orbital related subshells are possible. There is no chance of occupying 2 d orbitals. For that, certain reasons are there that will be explained in a atomic structure chapter. Now, let me explain how this organic chemistry is going to be introduced beautifully to the higher level concepts. First, what and all that 4 elements are there now. Here 2p subshell that will be having 2 orbitals, that is a 2px1 as well as a 2py1. And here 2s atomic orbital will be having 2 electrons. That's why the carbon always having 4 electrons in its valence shell. Here these electrons will be called as a valence shell electrons. That's why carbon will be having 4 valence shell electrons. And just imagine, this is a electron coming from s orbital, and this electron will be coming from also s orbital, and this is from 2px atomic orbital, and this is from 2py atomic orbital. Now let me clear about this particular concept. Here 2pz atomic orbital will be there, and that 2pz atomic orbital will be vacant. Dear students, see, most of the students they are not going to emphasize on this particular concept over here. Because of this, so many students will be get in a confusion mode. Why I am telling this particular orbital? It is just because of, see, what and all these electron will be present in the 2s atomic orbital during its excited state. Okay. What do you mean by excited state? If any electron, if it is present in a respective atomic orbital, and that particular orbital which is called as a ground state of an atom. Here, what and all electronic configuration I have written over here, that is a ground state electronic configuration. We know that each and every one of us, we are not going to be there in a ground state. Each and every one of us always try to get in an excited state. I am right or wrong? ಅಲ್ವಾ, ನಾವೆಲ್ಲರೂ ಕೂಡ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ ಇರಕ್ಕೆ ಇಷ್ಟಪಡಲ್ಲ. ಒಂದಲ್ಲ ಒಂದು ಆಕ್ಟಿವಿಟೀಸ್ ಅಲ್ಲಿ ಇನ್ವಾಲ್ವ್ ಆಗ್ತಾ ಇರ್ತೀವಿ. ಅದೇ ಟೈಪ್ ಅಲ್ಲಿ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಗಳು ಕೂಡ ಅದಕ್ಕೂ ಜೀವ ಇದೆ ಮಕ್ಕಳ. Each and every element will be having that excited state. During that excited state, all these chemical reactions are going to be happen. What and all organic reactions now we are going to see, that is just because of that excited state of the carbon atom. So many chapters thereafterwards, after studying that GOC, hydrocarbons, aldehydes and ketones and carboxylic acid, haloalkanes, haloarenes, amines, carboxylic acid, like that, so many extra chapters are going to come. All these chapters just because of the carbon compounds. How these carbon compounds are going to form different kinds of functional group, based on that, each and every chemical reactions are going to happen, and new products are going to be formed, and that products are going to be utilized for various pharmaceutical industries. Adakoskara, here we have to learn about the excited state. Here one electron which is present in the 2s atomic orbital, that will be, see, one electron that will be jumps into the 2pz atomic orbital. That's why the 2pz atomic orbital having also one electron, and 2px also having one electron, and 2py also having one electron. These 4 electrons will be represented around the carbon atom. That's why these 4 unpaired electrons will be able to form bond with the neighboring atom. What and all different atoms are going to come, based on that, this carbon atom is going to give its unpaired electron towards the atom which is approached towards to it. ಅದರ ಪಕ್ಕಕ್ಕೆ ಯಾರೆಲ್ಲ ಬರ್ತಾರೋ ಆ ಬರುವಂತ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಗಳಿಗೂ ಕೂಡ ಕಾರ್ಬನ್ ಓಪನ್ ಆಗಿ ಏನ್ ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ತನ್ನಲ್ಲಿದ್ದ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಗಳನ್ನ ಡೊನೇಟ್ ಮಾಡ್ತಾ ಬರುತ್ತೆ. Out of which one important compound, that is a hydrogen. We know that hydrogen will be having the atomic number that becomes equal to 1. Its electronic configuration becomes equal to 1s1. 4 such hydrogen atoms will be donating its electron towards the carbon atom. That's why the first simplest hydrocarbon that is going to be generated, that is called as a methane. Methane. From here onwards, our carbon compounds, innumerable. We can't imagine that kind of innumerable number of organic compounds are going to be introduced, and that kind of organic compounds have been generated already. We are going to study about that compounds under organic chemistry. Here that carbon, apart from the tetravalency nature, one more nature that will be have by our carbon compound, that is called as a catenation. Catenation. Now, what do you mean by catenation? These carbon compounds has the ability to form very long chain of carbon atoms, and which forms a very giant molecules. In this way, if any carbon atom which is joined with the another carbon atom, and it will be forming very large number of carbon atom having very giant molecule, ರಾಕ್ಷಸಾಕಾರದ ಒಂದು ದೊಡ್ಡ ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನು ಏನ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ, ಫಾರ್ಮೇಶನ್ ಮಾಡ್ತಾ ಹೋಗುತ್ತೆ. ಈ ಪ್ರೋಸೆಸ್ ಅನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ, ಕೆಟನೇಷನ್ ಅಂತ ಕರಿತೀವಿ. ಇಟ್ ಇಸ್ ಎ ಪ್ರೋಸೆಸ್ ಆಫ್ ಫಾರ್ಮಿಂಗ್ ವೆರಿ large number of carbon atom in the form of a giant molecule. That process is called as a catenation. That catenation is also due to its tetravalency nature. So here carbon atom can extend its carbon chain with the so many number of carbon atom. That's why this carbon chain will be continued to the large extent. Meanwhile, in this catenation property, if all the carbon atoms are present in a straight chain, sometimes these carbon atoms may form branched chain also. That's why here in under catenation we can call it as a straight chain of carbon atom, straight chain, as well as a branched chain. Under catenation property, each and every carbon elements, see, either it may continue in a straight chain or it may extend its branches either towards the lower side or it may be extend its carbon chain towards the upper side. So if any that branched structure of carbon atom will be having the branching only towards the lower side, then such structures are called as isostructures, and these structures are called as normal structures. In isostructure, one more possibility is there. From the same carbon atom, that branches that maybe takes place towards the upper mode also. During that time, what happens here? Carbon and carbon atom, it will having branches both towards the upper side as well as lower side. Then such structures are called as neostructures. Normal, iso as well as neo, these are the three structures that can be possible for a carbon atom when it undergoes a catenating property. After looking into its varieties of branching, now let me be having a discussion how these carbon compounds are going to be represented. We know that, see, when I am facing to you, only one face of mine is going to be visualized. Nana ondu bhaga matra nimge kanutte. That is called as a one-dimensional view. But we know that organic compounds also will be having three-dimensional structure. Nana back side nimge simultaneous nodakagalla video classes alli nodta iddaga. But when we are looking mine directly, then you can visualize my three-dimensional structure. ನನ್ನ ಫ್ರಂಟ್ ಆಸ್ ವೆಲ್ ಆಸ್ ಬ್ಯಾಕ್ ಸೈಡ್ ಪೋರ್ಷನ್ ಎಲ್ಲವನ್ನೂ ಕೂಡ ನೋಡ್ಕೊಳ್ಳೋಕ್ಕಾಗುತ್ತೆ. ಲೈಕ್ ದಟ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್ ವಿಲ್ ಬಿ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಇನ್ 3-dimensional structure. 3D representation of organic compound. 3D representation. Why? Someone will be thinking, why these 3D representation of organic compounds are very important? We know that when we are studying about chemical reactions, the orientation of that organic compound is also very important thing. ಯಾವ ರೀತಿಯಾಗಿ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ಒಂದು ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಆರ್ಗನೈಸ್ ಆಗಿರುತ್ತೆ. How that the three-dimensionally, if it is oriented, then how different other subreactant molecule which is going to be attacked to that particular carbon atom containing organic compound. Based on that, our chemical reactions are going to be decided. That means we know that just first I will write down what is the three-dimensional structure of methane. We know that carbon atom that will be represented by one small dot. That dot will represent a carbon atom. Meanwhile, while I am writing the three-dimensional structure for methane, okay, now methane will be having 4 hydrogen atom, 1 carbon atom, and see, one of the hydrogen atom will be represented like this, and another hydrogen atom will be represented like this. See, out of 4 hydrogen atom, 2 hydrogen atoms will be present on the plane of this particular surface. Just imagine, this is a plane, this particular board will be the plane. During that time, this hydrogen atom and carbon atom as well as this hydrogen atom will be present in one particular plane itself. And meanwhile, if any atom which is facing away from the observer, then that hydrogen atom will be represented by these dashed wedge like structure. Dashed wedge. ಇದನ್ನ ನಾವು dashed wedge structure ಅಂತ ಕರಿತೀವಿ. That means if that hydrogen atom, this is a 4 hydrogen atom, if we are going to consider 4 hydrogen atom, see the carbon atom that will be present at the center, and see one of the hydrogen atom, okay, that will be facing towards the observer. One of the hydrogen atom will be facing towards the observer, and one of the hydrogen atom that will be facing away from the observer. And these 2 hydrogen atom and carbon atom will be lie on the same plane. ಆವಾಗ ಏನಾಗುತ್ತೆ, ಈ 4 ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ನಲ್ಲಿ ಏನಾಗಿರುತ್ತೆ, ಒಂದು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ observer. ಈಗ just imagine you are the observer. This is the hydrogen atom which is facing towards the observer, and this hydrogen atom actually ಅದು ನಿಮ್ಗೆ ಕಾಣಲ್ಲ, that will be facing away from the observer. And these carbon atom as well as the hydrogen atom, 2 hydrogen atom that will lie on the same plane. Okay, the plane of these 2 structure may be vary, but carbon atom and 2 hydrogen atom that should be lie on the same plane. During that time, we can represent it in the form of dashed wedge if it is facing away from the observer, and if it is facing towards the observer, then that will be indicated by the solid wedge. Okay, thick line structure that will be indicated by a structure which is called as a solid wedge. This hydrogen atom which is facing towards the observer. ನಮ್ಮ ಕಡೆಗೆ ಏನಾಗಿರುತ್ತೆ, ಇದು ಫೇಸ್ ಆಗಿರುತ್ತೆ towards the observer. ಅದಾದ ನಂತರ which is facing away from the observer. This structure which is called as a 3-dimensional representation of a organic compound. Like that, today I have written only the simplest structure, that is methane. Like that, so many other organic compounds are going to come. Ethane, propane, each and every organic compounds that should be represented by using this kind of a 3-dimensional structure, so that we can easy to understand its chemical reactions. When it is reacted with so many other substrate molecules, how these reactions are going to be favored, and what and all products are going to be formed, that will be decided based on the orientation of the organic compound. Okay, next let me explain about how these organic compounds will be named, as well as how these organic compounds will be represented in different ways. There are three ways are used to represent organic compounds. Three ways are used to represent an organic compound. First way, that is a complete representation of organic compound. Complete representation. And second one, bond line representation of organic compound. Bond line representation. As well as another one that is called as a condensed representation of organic compound. Okay, na? Three ways are used to represent organic compound. In first, how that three-dimensionally structures are going to be written. Okay, we have look on it. Other nodidvi three-dimensional representation. Next, on the organic compound anna hege represent ಮಾಡ್ತಾ ಬರ್ಬೋದು. Okay, first I will start with the simple compound, then we will start with the IUPAC nomenclature, so that we can get a number of organic compounds. First and foremost, what and all the structure we have studied in our 10th standard. We know that if complete structure, I will write down the structure of C4H10 butane. Here butane will be having 4 carbon atom. That's why I should write down the 4 carbon atom, 1, 2, 3, 4 carbon atom and 10 hydrogen atoms. Each and every carbon atom that will be represented by one bond with the hydrogen atom. Then automatically, see, its complete structure is going to be written. Okay, complete structure of butane. Butane. While we are writing the complete structure of butane, okay, we have to look into the each and every bonds which is present around the carbon atom. Okay, so many students, they were taking this particular concept in a lighter way. But while we are writing a chemical reactions in detail, the structure is very, very crucial. Because most of the examination papers that will be given either bond line or condensed representation of organic compound. Dear students, okay, from Excellence NEET Academy, okay, from the 2007 onwards till today, we are having the plenty of experiments. In that, in experiment in the sense how we can teach the subject in a better way, how we can reach the students in a closer way, and how we can give each and every aspects to the students as a student friendly. Okay, these are all the experiments we did in our classes. And in these classes we found that, see, so many students they were lagging in organic chemistry just because of their drawback in their basic studies. While okay, we know that in order to write down the complete structure, it will be a tedious task. ಬಹಳ ಕಷ್ಟ ಆಗುತ್ತೆ. Each and every bond that should be mentioned over there. ಆಗ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಇಷ್ಟು ಲೈನ್ ಹಾಕ್ತಾ ಕೂರ್ಬೇಕು ನಾವು ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿನಲ್ಲಿ ಅಂತ ಥಿಂಕ್ ಮಾಡ್ತಾ ಇರ್ತೀರಾ. Don't think in that way. See, here we will study the subject in depth. How that carbon atom will be having all the hydrogen atoms and how this carbon atom is going to be structured. We know that each and every carbon atom will be having single bond around to it. Then its hybridization is sp3. That also we should know, sp3 hybridized carbon atom. If between the carbon atom double bond is there, then that hybridization is called as a sp2 hybridized carbon atom. If between the carbon atom triple bond is there, then that will be considered as a sp hybridized carbon atom. ಹಾಗಾಗಿ ಈ ಸ್ಟ್ರಕ್ಚರ್ ಅನ್ನ ಬರಿಬೇಕಾದ್ರೆ, ಕಂಪ್ಲೀಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಬರಿಬೇಕಾದ್ರೆ, so many students they were thinking, okay, why we have to spend that much of time? No, dear my students, okay, if you are going to consume that much of time with the patience, then definitely what and all reactions is going to be happen with respect to that particular carbon atom is going to be studied in detail. in upcoming classes, in other class schedules, I am going to show how these hydrogen atoms will be replaced by some other substrate molecules. ಬೇರೆ ಬೇರೆ ಸಬ್ಸ್ಟ್ರೇಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಏನ್ ಮಾಡುತ್ತೆ, ಈ ಹೈಡ್ರೋಜನ್ ಅನ್ನು ರಿಮೂವ್ ಮಾಡಿ ಆ ಜಾಗದಲ್ಲಿ ಯಾವುದನ್ನ ಕೂರಿಸುತ್ತೆ, ಬೇರೆ ಬೇರೆ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಅನ್ನ ಇಲ್ಲಿ ಇಂಟ್ರೊಡ್ಯೂಸ್ ಮಾಡುತ್ತೆ. ದಟ್ ವಿಲ್ ಬಿ ಸ್ಟಡಿಡ್ ಅಂಡರ್ homologous series. So the complete structure, this is the basic concept that should be studied under general organic chemistry. That's why right from the beginning itself, okay, we are giving the detailed structure about the organic compound. In upcoming higher classes, you will come to know what and all benefits will be having just by studying all these three structures. Okay, next, after the complete structure, bond line, we know that if 4 carbon atom is there, while we are writing bond line structure, we are going to put 4 dots at a non-collinear points. It should not be present in a straight line. Non-collinear, okay, 4 dots should be taken. Why? Because we are going to write down the structure for butane. So that non-collinear points that will be reached by using single line over here. See, this is a simple representation of a bond line for butane. Most of the students, they like this particular structure, but meanwhile they forget what and all hydrogen atoms will be present at these particular points. We should be kept in our mind, this particular carbon atom will be having 3 hydrogen atom, and this particular carbon atom will be having 2 hydrogen atom, and this particular carbon atom will be having 2 hydrogen atom, and this particular carbon atom will be having 3 hydrogen atom. This is a basic structure from where I am going to start the bond line representation. Here, that only that 4 structure, that is more than enough, that represent a bond line representation. And condensed structure, we know that 1, 2, 3, 4 carbon atom will be there. And how many carbon atoms will be present in a first carbon atom? 3 hydrogen atom will be there. All the 3 hydrogen atom will be written like this. See, condensed structure. With respect to the complete structure, I am going to write down here. And here 2 hydrogen atom will be there. That's why I will take CH2. And this particular carbon atom will be also having 2 hydrogen atom. So I will write down 2 hydrogen atom over here. And this particular carbon atom will be having 3 hydrogen atom. So I will write down CH3. Most of the textbooks that will represent a condensed representation of organic compound, and most of the competitive paper that will give rise to that bond line representation. ಹೆಚ್ಚಿನ JEE ಪೇಪರ್ ನಲ್ಲಿ ಬಾಂಡ್ ಲೈನ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಅನ್ನ ಕೊಟ್ಟಿರ್ತಾರೆ, ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲಿ ಕಂಡೆನ್ಸ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಆದ್ರೆ ನಾವು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ಬರಿಬೇಕಾದ್ರೆ ಅದರ ಕಂಪ್ಲೀಟ್ ಸ್ಟ್ರಕ್ಚರ್ ನ ಇಮ್ಯಾಜಿನೇಷನ್ ಬೇಕು ನಮಗೆ. That's why these are the 3 ways to represent some of the organic compounds. Now, apart from that, okay, butane, okay, I will consider pentanol. Pentane to all. Already some of the students, they know about this particular structure. In your 10th standard, you already learnt about the structure with respect to the pentane to all. Here, 5 carbon atom must be there. Okay, 1, okay, 2, 3, 4, 5 carbon atom must be there. And in the second carbon atom, we should write down the functional group, that is alcohol, OH. And each and every carbon atom that will be represented by the hydrogen atom here. Here also hydrogen atom, here also hydrogen atom, and here also hydrogen atom. This is the structure of pentanol, the complete structure of pentanol, pentane to all. Now, I will write down the bond line representation for that same compound, that is a pentanol here. Okay, how to write down the bond line representation? As usual, 1, 2, 3, 4, 5 non-collinear dots should be taken. That will represent the carbon atom, and all the carbon atom will be joined by a line. Now you can take from this particular carbon atom, this is a second carbon atom, ಎರಡನೇ carbon atom ಇಲ್ಲಿ, ಆ ಸೆಕೆಂಡ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಲ್ಲಿ ಒಂದು ಲೈನ್ ಹೇಳ್ಬಿಟ್ಟು ಯಾವ್ದನ್ನು ಬರೀತೀನಿ ನಾನು OH ಅಂತ ತೆಗೆದುಕೋತೀನಿ. Okay, this is the bond line representation of a pentane to all. And here the condensed representation ಗೊತ್ತಿದೆ ನಿಮಗೆ 1 2 3 4 5 ಕಾರ್ಬನ್ ಆಟಮ್ will be there. ಆ 5 ಕಾರ್ಬನ್ ಆಟಮ್ ನಲ್ಲಿ ಎಲ್ಲಾ ಕಾರ್ಬನ್ ಆಟಮ್ ನಲ್ಲಿ ಕೂಡ ಬಾಂಡ್ ಅಂತ ತೆಗೆದುಕೋತೀನಿ. And here 3 hydrogen atom, here 2 hydrogen atom, and here also 2 hydrogen atom, and here 1 OH and 1 hydrogen atom, and here 3 hydrogen atom. This is the condensed representation of a pentane to all. Meanwhile, one more structure, hexanoic acid. Okay, hexanoic acid. How to write down the complete bond line and condensed structure for hexanoic acid? First, see here, hexane, that means the total 6 carbon atom must be there. First, I will write down 1, 2, 3, 4, 5, 6 carbon atom. And either this will be considered as a first carbon atom or this may be considered as a first carbon atom. ಈ ಎರಡರಲ್ಲಿ ಯಾವುದನ್ನು ಬೇಕಾದರೂ ನೀವು ಫಸ್ಟ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಂತ ತೆಗೆದುಕೋಬಹುದು. ಆ ಫಸ್ಟ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಇದನ್ನು ತೆಗೆದುಕೊಂಡ್ಬಿಟ್ರೆ ಇಲ್ಲಿ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್, ಒಯಿಕ್ ಆಸಿಡ್, ಓಕೆ ಎವ್ರಿವನ್ ನೋಸ್ ಅಬೌಟ್ ಇಟ್. ಒಯಿಕ್ ಆಸಿಡ್ ಅಂತಿದ್ರೆ ಅದು ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಅಂತ ಅರ್ಥ. ಆ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ನ ಸ್ಟ್ರಕ್ಚರ್ ಇಲ್ಲಿ ಸಿ ಡಬಲ್ ಬಾಂಡ್ O ಆಸ್ ವೆಲ್ ಆಸ್ ಹಿಯರ್ OH ಅಂತ ತೆಗೆದುಕೋತೀನಿ. See, each and every part which has been shown over here, COOH group, and between the carbon atom I am going to put down okay single bond. Next, each and every carbon atom ಅದಕ್ಕೆ ಯಾವ್ದಂತ ತೆಗೆದುಕೋತೀನಿ ನಾನು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇಂದ ಅದನ್ನ ಫಿಲ್ ಅಪ್ ಮಾಡ್ಕೋತೀನಿ. ಓಕೆ, ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಇಂದ ಅದನ್ನ ಫಿಲ್ ಅಪ್ ಮಾಡ್ಕೋತೀನಿ. ಇದೇನಾಯ್ತು, ಈಗ ಕಂಪ್ಲೀಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ದಿ ಓಕೆನಾ, ಕಂಪ್ಲೀಟ್ ಸ್ಟ್ರಕ್ಚರ್ ಆಫ್ ದಿ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್, ದಟ್ ಈಸ್ ಅ hexanoic acid. ನೆಕ್ಸ್ಟ್ ಸೇಮ್ ಆ hexanoic acid ನ ಬಾಂಡ್ ಲೈನ್ ಬರಿಬೇಕು. 1 2 3 4 5 6 ಕಾರ್ಬನ್ ಆಟಮ್ ಅನ್ನ ಒಂದೇ ಲೈನ್ ಅಲ್ಲಿ ಬರೆಯಲ್ಲ, ನಾನ್ ಕೊಲಿನಿಯರ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಬರೀತೀನಿ. ಆ 6 ಡಾಟ್ ಅನ್ನು ಕೂಡ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ಜಾಯಿನ್ ಮಾಡ್ತೀನಿ. 6 ಡಾಟ್ ಅನ್ನು ಕೂಡ ಜಾಯಿನ್ ಮಾಡ್ತೀನಿ. ಇಲ್ಲಿ ಫಸ್ಟ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಇದು, ದಿಸ್ ಇಸ್ ದ ಫಸ್ಟ್ ಕಾರ್ಬನ್ ಆಟಮ್. ಆ ಕಾರ್ಬನ್ ಆಟಮ್ ನಲ್ಲಿ ನಾನು ಯಾವ್ದಂತ ತೆಗೆದುಕೋತೀನಿ, ಸಿ ಡಬಲ್ ಬಾಂಡ್ O, ನೆಕ್ಸ್ಟ್ ಯಾವ್ದು ತೆಗೆದುಕೋತೀನಿ, OH. ಸಿಯ ಸಿ ಡಬಲ್ ಬಾಂಡ್ OH ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್. ಇದನ್ನ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಇದನ್ನು ತೋರಿಸ್ತೀನಿ. ನೆಕ್ಸ್ಟ್ ಯಾವುದೇ ಪೊಸಿಷನ್ ಅನ್ನು ಕೂಡ ನೀವು ಮೆನ್ಷನ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಓಕೆ, ದ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ that will be represented by okay its original functional group and that will be represented in terms of a bond line, and all other carbon atom containing hydrogen atom need not be represented. ಇಲ್ಲಿ ಲಾಸ್ಟ್ ಬಂದಾಗ ಗೊತ್ತಿರುತ್ತೆ, ಸಿ ಡಬಲ್ ಬಾಂಡ್ OH ಅಂತ ತೆಗೆದುಕೋತೀನಿ. and 1 2 3 4 5 6 carbon atom, here 3 and here 2 hydrogen atom, and here also 2 hydrogen atom, 2 hydrogen atom, 2 hydrogen atom, and between the carbon atom we should take one simple bond. In this way we can beautifully represent the condensed structure of organic compounds. After studying all these 3 ways of representation of organic compound, now let me have some of the concepts related to the homologous series. What do you mean by homologous series? Here, when we are looking into basic structure of the organic compound, it starts from the first carbon atom. We know that. Even we are looking into the hydrocarbons, especially that you learnt in your 10th standard also, alkanes, alkenes as well as alkynes. These are the 3 hydrocarbon part that is going to be coming under in your syllabus. Here each and every carbon atom that will be successively added with one more carbon atom, so that the carbon chain is going to be elaborated, right from the first carbon atom up to 10 carbon atom, 20, 30 like that, innumerable number of carbon atoms are going to be added together. In this way, if any successive member of a particular organic compound will be having CH2 as an additive member, then such types of series are called as a homologous series. That means the member which is coming under the organic compound, the successive member that will be coming under organic compound, that will be differ by one methylene group. ಆ CH2 group ಅನ್ನು ನಾವೇನಂತ ಕರಿತೀವಿ ಗೊತ್ತಾ? ಮಿಥಿಲಿನ್ ಅಂತ ಕರಿತೀವಿ. See, most of the students they will not know about the clear picture about our organic chemistry, basic concepts, general concepts. This structure which will be called as a methane, when one hydrogen atom will be removed from this particular carbon atom, then that will be considered as a methyl, and one more hydrogen atom if it is replaced or it is removed, then that will be known as a methylene group. Methane, methyl and methylene. So this methylene group will be added successively to the carbon atom, so that very large number of organic compounds we are going to get under a particular organic compounds, especially in case of alkene as well as alkynes. Okay. Next, let me have a discussion related to how IUPAC nomenclature of these organic compounds can be written. We have seen so many organic compounds in our previous studies. Am I right? Okay. Some of the compounds which has been coming under alcohols as well as carboxylic acid and amines, aldehydes and ketones. These are all the different organic compounds. When we are looking into any organic compound which you will be having, I will explain the basic organic compound which is coming under to it. If any organic compound that will be end with the functional group COOH, then that will be known as a carboxylic acid. Carboxylic acid. Next, if any organic compound, so many functional groups are there, but initially I will explain one of the few important organic compounds and its a functional group that will be coming under to it. Okay, carboxylic acid, and next one, that is a sulfonic acid. And esters. Sulfonic acid, esters, and apart from that, acid chlorides, RC double bond O Cl, that is called as a acid chloride. Listen carefully and look into the functional group carefully. RCOCl, and then that will be RC double bond O R dash, ketones. Here CO will be acts like a functional group. Then C double bond O H, aldehydes. Aldehydes. Then OH, alcohol. Alcohols. Next, amines, NH2. first I have taken only few examples. Apart from that, 20 to 30 different organic compound functional groups are going to come. ನಾವು ಒಮ್ಮೆಲೆ ಎಲ್ಲವನ್ನು ಕೂಡ ತಿಳ್ಕೊಂಡು ಅದನ್ನ ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಬೇಡ. ದಿಸ್ ಇಸ್ ದ ಆರ್ಡರ್ ಆಫ್ ರಿಯಾಕ್ಟಿವಿಟಿ. ಅಂದ್ರೆ ಏನಾಗಿರುತ್ತೆ, ಇಫ್ ಎನಿ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ದಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ carboxylic acid as a functional group, then that will be given as a highest order of priority. ಇದಂತೆಲ್ಲ ಹೇಗೆ ಅಂತ ಹೇಳಿದ್ರೆ, ನೆಕ್ಸ್ಟ್ ಸಲ್ಫೋನಿಕ್ ಆಸಿಡ್, ನೆಕ್ಸ್ಟ್ ಯಾವ್ದು ಬರುತ್ತೆ, ಎಸ್ಟರ್ಸ್ ಬರುತ್ತೆ, ಎಸ್ಟರ್ಸ್ ಆದ ನಂತರ ಆಸಿಡ್ ಕ್ಲೋರೈಡ್ಸ್ ಬರುತ್ತೆ, ಅದಾದ ನಂತರ ಕೀಟೋನ್ಸ್ ಬರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ಆಲ್ಡಿಹೈಡ್ಸ್ ಬರುತ್ತೆ, ನೆಕ್ಸ್ಟ್ ಆಲ್ಕೋಹಾಲ್ ಬರುತ್ತೆ, ಅದಾದ ನಂತರ ನೆಕ್ಸ್ಟ್ ಅಮೈನ್ಸ್, ಇದಾದ ನಂತರ ನೆಕ್ಸ್ಟ್ ಗೊತ್ತಿದೆ ಡಬಲ್ ಬಾಂಡ್, ಟ್ರಿಪಲ್ ಬಾಂಡ್, ಆಲ್ಕೈನ್ಸ್. ನಾವು ನೋಡ್ತಾ ಹೋದ್ರೆ ಇನ್ನು ಕೂಡ ವೆರೈಟಿ ಆಫ್ ಡಿಫರೆಂಟ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಮ್. ಬಟ್ in order to introduce that our IUPAC concept, okay na, in order to introduce our IUPAC concept, in order to give the basic idea, I am going to take some of the functional groups over here. ಇದರಿಂದ ಏನು ಬೆನಿಫಿಟ್, ಏನು ಬೆನಿಫಿಟ್ ಏನು, ಇದನ್ನೆಲ್ಲ ನಾವು ಏನ್ ಮಾಡ್ತೀವಿ ಅಂತ ಹೇಳಿದ್ರೆ PUC ಅಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡುವಂತ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾಂಪೌಂಡ್ಸ್ ಅನ್ನು ಮಾತ್ರ ನಾನು ಲಿಸ್ಟ್ ಮಾಡಿದ್ದೀನಿ. Apart from that, so many other functional group is also going to come that will be given in your JEE advanced as well as higher level competitive examinations. Okay, ನಮ್ಮ ಎಲ್ಲ ಇನ್ಸ್ಟಿಟ್ಯೂಟ್ಗಳಲ್ಲಿ ಕೂಡ ಏನಾಗಿರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಎಕ್ಸಲೆನ್ಸ್ ನೀಟ್ ಅಕಾಡೆಮಿಯಲ್ಲಿ ಶಶಿಕರ್ ಸರ್ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿ ಈ ಎಲ್ಲ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಗಳಿಗೆ ರಿಲೇಟೆಡ್ ಬೇಸಿಕ್ ಐಡಿಯಾಸ್ ಗಳನ್ನ, ಫೀಚರ್ಸ್ ಗಳನ್ನ ಹಾಕೊಟ್ಬಿಟ್ಟು ಮಕ್ಕಳಿಗೆ ಅದನ್ನ ಈಸಿ ಆದಂತ ರೀತಿಯಲ್ಲಿ ನಾವು ಕನ್ವೆ ಮಾಡಬೇಕು ಎಂಬ ದೃಷ್ಟಿಕೋನದಲ್ಲಿ ಇಟ್ಕೊಂಡು ಈ ಕ್ಲಾಸಸ್ ಎಕ್ಸಲೆನ್ಸ್ ನೀಟ್ ಅಕಾಡೆಮಿ ಅಂಡರ್ ಅಲ್ಲಿ ನಾವು ಈ ಕ್ಲಾಸಸ್ ಗಳನ್ನು ಆರ್ಗನೈಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಇದರ ಮೈನ್ ಬೆನಿಫಿಟ್ ಯಾರಿಗೆ ಸಿಗ್ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ಸ್ಟೂಡೆಂಟ್ಸ್ ಗಳಿಗೆ ಸಿಗ್ಬೇಕು ಅಂತ. ಓಕೆ, ದೇರ್ ಆರ್ ನಂಬರ್ ಆಫ್ ಯೂಟ್ಯೂಬ್ ಅಂಡ್ ಅದರ್ ಕ್ಲಾಸಸ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್, ನಮ್ಗೆ ಗೊತ್ತಿದೆ. ಬಟ್ ದಿಸ್ ವಿಲ್ ಬಿ ಒನ್ ಆಫ್ ದಿ ಕ್ರೂಷಿಯಲ್ ಒನ್ ಅಂಡ್ ಡಿಫರೆಂಟ್ ಒನ್. ಸ್ಲೋಲಿ ಅಂಡ್ ಸ್ಟಡಿಲಿ ವಿ ಕ್ಯಾನ್ ವಿನ್ಸ್ ದ ರೇಸ್ ಅಂತ ಒಂದು ಗಾದೆ ಮಾತಿದೆ. ನಿಧಾನಕ್ಕೆ ಹೋಗೋಣ, ಪ್ರತಿಯೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ಅನ್ನ ಮನಸ್ಸಿಟ್ಟು ಬೇಸ್ ಟು ಬೇಸ್, ರೂಟ್ ಟು ರೂಟ್ ಅದನ್ನ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಹೋದ್ರೆ ಸಕ್ಸಸ್ ಖಂಡಿತ ನಮ್ಗೆ ಸಿಗುತ್ತೆ ಅಂತ ಹೇಳ್ಕೊಟ್ಟವರು ನಮ್ಮ ಎಕ್ಸಲೆನ್ಸ್ ನೀಟ್ ಅಕಾಡೆಮಿ ಚೇರ್ಮನ್ ಆಗಿರುವಂತ ಶಶಿಕರ್ ಸರ್ ಅವರು. ಆ ಸೇಮ್ ಅವರು ಹಾಕೊಟ್ಟಿರುವಂತ ಆ ಸೇಮ್ ಮಾರ್ಗದರ್ಶನದ ಮೂಲಕನೇ ನಾವೇನ್ ಮಾಡ್ತಾ ಹೋಗ್ತಾ ಇದೀವಿ, ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಗಳನ್ನ ಒಂದು ಈಸಿಯಾಗಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಗಳಿಗೆ ರೀಚ್ ಮಾಡಬೇಕು ಅಂತ ಅದನ್ನ ಒಂದು ವಿಡಿಯೋ ಕ್ಲಾಸಸ್ ಗಳ ಮೂಲಕ ನಮ್ಮ ಸಣ್ಣ ಪ್ರಯತ್ನವನ್ನು ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಇಲ್ಲಿ ಆ ಜನರಲ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕೆಮಿಸ್ಟ್ರಿ ಕಾನ್ಸೆಪ್ಟ್ ಅಂತ ತೆಗೆದುಕೊಂಡಾಗ ನನ್ಗೆ ಹೊಳೆದಿರುವಂತದ್ದು ಇಷ್ಟೇ. ದೇರ್ ಆರ್ 20 to 30 ಡಿಫರೆಂಟ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ಸ್ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಕಮ್. ಆದ್ರೆ ಅದರಲ್ಲಿ ಇದಿಷ್ಟನ್ನು ಮಾತ್ರ ಸೆಲೆಕ್ಟ್ ಮಾಡಿಕೊಂಡು ನಾನು ಒಂದು ಸ್ವಲ್ಪ IUPAC nomenclature ಅನ್ನು ಈಸಿಯಾಗಿ ನಿಮ್ಗೆ ರೀಚ್ ಆಗುವಾಗ ಟ್ರೈ ಮಾಡ್ತೀನಿ. ವಿ ನೋ ದಟ್ ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ಕಾರ್ಬನ್ ಆಟಮ್, ಓಕೆನಾ, ದಟ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಕಾರ್ಬನ್ ಚೈನ್. ಓಕೆನಾ, ಒಂದೆಲ್ಲ ಡಿಫರೆಂಟ್ ಆಗಿ ನಾನು ಕೊಡ್ತೀನಿ. ಈ ಎಲ್ಲ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಗಳು ಈ ರೀತಿಯಾಗಿದ್ದಾಗ ಇಲ್ಲಿ ಏನಾಗಿರ್ಬೋದು, ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಯಾವ್ದ್ರಲ್ಲಿ ಇರ್ಬೋದು, ಫಸ್ಟ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಅಲ್ಲಿ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಇರ್ಬೋದು, COOH. Apart from that particular carbon atom, some other carbon atom will be having substituent groups. See here, chlorine will be present as a substituent group. ಅದಾದ ನಂತರ ಈ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಯಾವ್ದಂತ ತೆಗೆದುಕೊತೀನಿ ನಾನು, CH3 will be taken as a substituent group. ಅಂದ್ರೆ if any group that will be present as a locant with respect to the carbon skeleton, ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ಏನ್ ಬರ್ದಿದೀನೋ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ ನಾವೇನಂತ ಕರಿತೀವಿ, ಕಾರ್ಬನ್ ಸ್ಕೆಲಿಟನ್ ಅಂತ ಕರಿತೀವಿ. ಅಂಡ್ ದೀಸ್ ಕಾರ್ಬನ್ ಅಂಡ್ ಸ್ಕೆಲಿಟನ್ ದಟ್ ವಿಲ್ ಬಿ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಎ ಸ್ಟ್ರೈಟ್ ಚೈನ್. ಇಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ನಂಬರ್ ಆಫ್ ಕಾರ್ಬನ್ ಆಟಮ್ ಸ್ಕೆಲಿಟನ್ ನಮ್ಗೆ ಸಿಗ್ಬೇಕು IUPAC nomenclature ಕೊಡ್ಬೇಕಾದ್ರೆ. ಅದಕ್ಕೋಸ್ಕರ ಒಂದು ಫಸ್ಟ್ ರೂಲ್ ಅನ್ನೇ ಸೆಟ್ ಮಾಡಿದ್ರು, ಲಾಂಗೆಸ್ಟ್ ಚೈನ್ ರೂಲ್. ಲಾಂಗೆಸ್ಟ್ ಚೈನ್ ರೂಲ್. ವಾಟ್ ಇಟ್ ಸೇಸ್, ಲಾಂಗೆಸ್ಟ್ ಚೈನ್ ರೂಲ್? While we are giving IUPAC nomenclature to an organic compound, that organic compound should be selected based on the carbon atom, and that carbon atom should be get in a largest number. Largest number ಯಾವಾಗ ಸಿಗುತ್ತೆ ನಮ್ಗೆ ನೋಡಿ, ಈ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ನಾನು ಏನ್ ಕೊಡ್ತೀನಿ, 1 ನಂಬರ್ ಕೊಡ್ತೀನಿ, ಇದಕ್ಕೆ 2. ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಇದೆ, ಇಲ್ಲಿ ಒಂದ್ ವೇಳೆ 3 ನಂಬರ್ ಕೊಟ್ಬಿಟ್ರೆ ಲಾಂಗೆಸ್ಟ್ ಚೈನ್ ರೂಲ್ ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ. 3 ನಂಬರ್ ಇಲ್ಲಿ ಕೊಡಕ್ಕಾಗಲ್ಲ, ಅಲ್ಲಿಗೆ ರಿಸ್ಟ್ರಿಕ್ಟ್ ಆಗ್ಬಿಡುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ನಾನು ಕಂಟಿನ್ಯೂ ಕೊಡಕ್ಕಾಗಲ್ಲ ನಂಬರ್ಸ್, ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ 1 2 ಕೊಟ್ಟಾದ ನಂತರ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ಗೆ ಯಾವ ನಂಬರ್ ಕೊಡ್ತೀನಿ 3. ಕಂಟಿನ್ಯೂ ಆಗುತ್ತೆ ಚೈನ್. ನೋಡಿ ಬಾಂಡ್ ಕಂಟಿನ್ಯೂ ಆಗೋ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ನಾವು ನಂಬರ್ಸ್ ಅನ್ನ ಕೊಡ್ತಾ ಬರಬೇಕು. ಫಸ್ಟ್ ಸೆಕೆಂಡ್ ಥರ್ಡ್ ನಂಬರ್ ಕೊಟ್ಟಿದ್ದೀನಿ, ಇದಕ್ಕೆ 4th ನಂಬರ್ ಕೊಡ್ತೀನಿ, ಇದಕ್ಕೆ 5th ಕೊಡ್ತೀನಿ, ಇದಕ್ಕೆ 6th ಕೊಡ್ತೀನಿ. ಮತ್ತೆ ಉಳಿದಿರುವಂತದ್ದೆಲ್ಲವನ್ನು ಕೂಡ ಕಂಡೆನ್ಸ್ಡ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಅಲ್ಲಿ ಬರ್ಕೋತೀನಿ. CH2 CH2 ಇಲ್ಲಿ CH ಅಂತ ತೆಗೆದುಕೋತೀನಿ. ಓಕೆ, ಇಲ್ಲಿ ಇನ್ನೊಂದು ಹೈಡ್ರೋಜನ್ ಆಟಮ್ ಬರೀಬೇಕು ನಾನು. ಓಕೆ, COH ಎಲ್ಲ ಕಾರ್ಬನ್ ಟೆಟ್ರಾವ್ಯಾಲೆನ್ಸಿ ಕಂಪ್ಲೀಟ್ ಆಯ್ತು. ಲಾಂಗೆಸ್ಟ್ ಚೈನ್ ಅನ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ಆ ಲಾಂಗೆಸ್ಟ್ ಚೈನ್ ಎಷ್ಟಿದೆ ಇಲ್ಲಿ ಟೋಟಲ್ 6 ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಇದೆ. ಹಾಗಾಗಿ ನಾನೊಂದು ಸಿಂಪಲ್ ಫಾರ್ಮುಲಾವನ್ನು ಕೊಡ್ತೀನಿ ಮಕ್ಕಳ. ಎಕ್ಸಲೆನ್ಸ್ ಅಲ್ಲಿ ನಾವು ಮಾಡ್ಕೊಂಡಿರುವಂತ ಮತ್ತು ಆಲ್ರೆಡಿ NCERT ಬುಕ್ ಅಲ್ಲಿ ಇದೆ, ಅದನ್ನ ಹೆಚ್ಚಿನ ಸ್ಟೂಡೆಂಟ್ಸ್ ಅದನ್ನ ಇನ್ ಡೆಪ್ತ್ ನೋಡ್ಕೊಂಡಿರಲ್ಲ. ಹೇಗಿರುತ್ತೆ ಆ ಫಾರ್ಮುಲಾ ಅಂತ ಹೇಳಿದ್ರೆ, ಫಸ್ಟ್ ಯಾವುದೇ ಒಂದು ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ IUPAC ನೇಮ್ ತೆಗೆದುಕೋಬೇಕಾದ್ರೆ ರೂಟ್ ವರ್ಡ್ ಅನ್ನ ಮೊದಲು ಬರ್ಕೋಬೇಕು. ರೂಟ್ ವರ್ಡ್ ಆದ ನಂತರ ನೆಕ್ಸ್ಟ್ ಪ್ರೈಮರಿ ಸಫಿಕ್ಸ್ ಅಂತ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ಬರುತ್ತೆ. ಪ್ರೈಮರಿ ಸಫಿಕ್ಸ್ ಏನು ಕಷ್ಟ ಇಲ್ಲ ಇದು. ಓಕೆ, ಇನ್ ಡೀಟೇಲ್ ಆಗಿ ಆ NCERT ಸಿಲೆಬಸ್ ಅಲ್ಲಿ ಅದನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ, ನಾನು ಅದನ್ನ ಸಮ್ಮರೈಸ್ ಮಾಡಿ ನಿಮ್ಗೆ ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಪ್ರೈಮರಿ ಸಫಿಕ್ಸ್ ವಿಚ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಬಿಟ್ವೀನ್ ದಿ ಕಾರ್ಬನ್ ಆಟಮ್ ವಿ ಹ್ಯಾವ್ ಟು ಅಬ್ಸರ್ವ್ ವೆದರ್ ಇಟ್ ಹ್ಯಾಸ್ ಅ ಸಿಂಗಲ್ ಬಾಂಡ್ ಆರ್ ಡಬಲ್ ಬಾಂಡ್. ಹಿಯರ್ ಬಿಟ್ವೀನ್ ದಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಎಲ್ಲ ನೋಡ್ತಾ ಇದ್ದೀರಾ ನೀವು, ಏನ್ ಕಾಣ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಸಿಂಗಲ್ ಬಾಂಡ್ ಕಾಣ್ತಾ ಇದೆ. ಆವಾಗ ಪ್ರೈಮರಿ ಸಫಿಕ್ಸ್ ಏನಾಗುತ್ತೆ AN. ಅದೇ ಯಾವ್ದಾದ್ರೂ ಕಾರ್ಬನ್ ಆಟಮ್ ಬಿಟ್ವೀನ್ ದಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಎಲ್ಲಾದ್ರೂ ಒಂದು ಕಡೆ ಡಬಲ್ ಬಾಂಡ್ ಬಂದ್ಬಿಟ್ರೆ ಆಗ ಪ್ರೈಮರಿ ಸಫಿಕ್ಸ್ ಏನಾಗುತ್ತೆ EN. ಆಲ್ಕೀನ್ ವಿಲ್ ಬಿ ರೆಪ್ರೆಸೆಂಟೆಡ್ ಬೈ ಎ ಪ್ರೈಮರಿ ಸಫಿಕ್ಸ್ ಬೈ ಎ ವರ್ಡ್ ಕಾಲ್ಡ್ EN. ಅದೇ ಎಲ್ಲಾದ್ರೂ ಈ ಕಾರ್ಬನ್ ಆಟಮ್ಸ್ ಗಳ ನಡುವೆ ಟ್ರಿಪಲ್ ಬಾಂಡ್ ಬಂದ್ಬಿಟ್ರೆ ಬಿಟ್ವೀನ್ ದಿ ಕಾರ್ಬನ್ ಆಟಮ್, ಆವಾಗ ಆ ಪ್ರೈಮರಿ ಸಫಿಕ್ಸ್ ಯಾವ್ದಾಗುತ್ತೆ YN ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಲಾಸ್ಟ್ ಒನ್ ಪ್ರೈಮರಿ ಸಫಿಕ್ಸ್ ಆದ ನಂತರ ನೆಕ್ಸ್ಟ್ ಸೆಕೆಂಡರಿ ಸಫಿಕ್ಸ್ ಅಂದ್ರೆ ಇದಿಷ್ಟು ಕೂಡ ನಾನು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ತೆಗೆದುಕೊಂಡಿದ್ದೀನಲ್ಲ, all these functional groups if it is present that will be ended with the secondary suffix. ನೆಕ್ಸ್ಟ್ ರೂಟ್ ವರ್ಡ್ ಗಿಂತ ಮುಂಚೆ ಬರಬೇಕಾಗಿರುವಂತದ್ದು ಯಾವುದು ಅಂತ ಹೇಳಿದ್ರೆ ಅರೇಂಜ್ಮೆಂಟ್ ಆಫ್ ಪ್ರಿಫಿಕ್ಸಸ್ ಅಂದ್ರೆ ಯಾವುದು, ಈ ಕಾರ್ಬನ್ ಸ್ಕೆಲಿಟನ್ ಅಲ್ಲಿ ಸೈಡ್ ಚೈನ್ ಅಲ್ಲಿ ಯಾವ್ದಿದೆ ಕ್ಲೋರಿನ್ ಇದೆ, ಅದಾದ ನಂತರ ಮಿಥೈಲ್ ಇದೆ. ಕ್ಲೋರಿನ್ ಇದ್ದಾಗ ಆ ಕ್ಲೋರಿನ್ ಅನ್ನ ಯಾವ ವರ್ಡ್ ಇಂದ ಯೂಸ್ ಮಾಡ್ತೀವಿ ನಾವು, ಕ್ಲೋರೋ ಹೇಳುವಂತ ವರ್ಡ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಇಲ್ಲಿ ಯಾವ್ದನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ ನಾವು ಮಿಥೈಲ್. ಈಗ ಇದು ಪ್ರಿಫಿಕ್ಸಸ್, ಅರೇಂಜ್ಮೆಂಟ್ ಆಫ್ ಪ್ರಿಫಿಕ್ಸಸ್ ಅಂತ ತೆಗೆದುಕೋತೀನಿ. ಅರೇಂಜ್ಮೆಂಟ್ ಆಫ್ ಪ್ರಿಫಿಕ್ಸಸ್, ಈ ಪ್ರಿಫಿಕ್ಸಸ್ ಅನ್ನ ಅರೇಂಜ್ಮೆಂಟ್ ಮಾಡ್ಕೋಬೇಕು ಅಂತ ಆದ್ರೂ ಕೂಡ ಅಲ್ಲೊಂದು ರೂಲ್ ಇದೆ ಮಕ್ಕಳ. ಇಲ್ಲಿ ಏನ್ ತೆಗೆದುಕೋಬೇಕಾಗತ್ತೆ, ಓಕೆ ಎರಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ಸ್ ಗಳಿದೆ. ಆ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ಸ್ ಗಳನ್ನ ಮಾತ್ರ ನಾವೆಲ್ಲಿ ತೆಗೆದುಕೋತೀವಿ ಪ್ರಿಫಿಕ್ಸಸ್ ಅಂಡರಲ್ಲಿ ತೆಗೆದುಕೋತೀವಿ. ಲೊಕ್ಯಾಂಡ್ಸ್ ಈ ಕಾರ್ಬನ್ ಸ್ಕೆಲಿಟನ್ಗೆ ಯಾವ್ದನ್ನೆಲ್ಲ ನೀವು ನಂಬರ್ 1 2 3 4 5 ಆ ಲಾಂಗೆಸ್ಟ್ ಚೈನ್ ಅನ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೊಂಡಾದ ನಂತರ ಬೇರೆ ಯಾವುದೆಲ್ಲ ಗ್ರೂಪ್ಸ್ ಗಳು ಉಳಿಯುತ್ತೋ ಅವುಗಳೆಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಗ್ರೂಪ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ಲೊಕ್ಯಾಂಡ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಆ ಲೊಕ್ಯಾಂಡ್ಸ್ ಗಳನ್ನೆಲ್ಲ ನಾವೆಲ್ಲಿ ತೆಗೆದುಕೋತೀವಿ ಈ ಅರೇಂಜ್ಮೆಂಟ್ ಆಫ್ ಪ್ರಿಫಿಕ್ಸಸ್ ಅಲ್ಲಿ ತೆಗೆದುಕೋತೀವಿ. ಇಲ್ಲಿ ಈ ಕಾರ್ಬನ್ ಸ್ಕೆಲಿಟನ್ ಅಲ್ಲಿ ಮಿಥೈಲ್ ಗ್ರೂಪ್ ಇದೆ, ಕ್ಲೋರೋ ಗ್ರೂಪ್ ಇದೆ. ಈ ಎರಡರಲ್ಲಿ ಆಲ್ಫಾಬೆಟಿಕಲ್ ಆರ್ಡರ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಬರುವಂತದ್ದು ಯಾವ್ದಿರುತ್ತೆ, ಕ್ಲೋರೋ ಕಮ್ಸ್ ಫಸ್ಟ್ ಅಂಡ್ ಮಿಥೈಲ್ ಕಮ್ಸ್ ನೆಕ್ಸ್ಟ್. ದಟ್ಸ್ ವೈ ಇಟ್ಸ್ ನೇಮ್ ವಿಲ್ ಬಿ ಸ್ಟಾರ್ಟೆಡ್ ವಿತ್ ದ ಅರೇಂಜ್ಮೆಂಟ್ ಆಫ್ ಪ್ರಿಫಿಕ್ಸಸ್. ಇಲ್ಲಿ ಏನ್ ತೆಗೆದುಕೋತೀನಿ, ಓಕೆ ಫಸ್ಟ್ ನಾನು ಯಾವ್ದನ್ನು ತೆಗೆದುಕೋತೀನಿ ಕ್ಲೋರೋ ಗ್ರೂಪ್ ಅನ್ನ ತೆಗೆದುಕೋತೀನಿ. ಹಾಗಾಗಿ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀನಿ. IUPAC ನೇಮ್ 3 ಕ್ಲೋರೋ 2 ಮಿಥೈಲ್ 2 ಕ್ಲೋರೋ 3 ಕ್ಲೋರೋ 2 ಮಿಥೈಲ್. ನೆಕ್ಸ್ಟ್ ರೂಟ್ ವರ್ಡ್ 6 ಕಾರ್ಬನ್ ಆಟಮ್ ಇದೆ, ಹಾಗಾಗಿ ರೂಟ್ ವರ್ಡ್ ಯಾವ್ದಂತ ತೆಗೆದುಕೋತೀನಿ ಹೆಗ್ಸ್. ಬಿಟ್ವೀನ್ ದಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಸಿಂಗಲ್ ಬಾಂಡ್ ಇದೆ, ಹಾಗಾಗಿ ಏನ್ ತೆಗೆದುಕೋತೀನಿ AN. ಪ್ರೈಮರಿ ಸಫಿಕ್ಸ್ ಎಲ್ಲ ಬಿಟ್ವೀನ್ ದಿ ಕಾರ್ಬನ್ ಆಟಮ್ ಸಿಂಗಲ್ ಬಾಂಡ್ ಇದೆ, ಹಾಗಾಗಿ AN ಅಂತ ತೆಗೆದುಕೋತೀನಿ. ಸೆಕೆಂಡರಿ ಸಫಿಕ್ಸ್ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ಇದ್ರೆ ಆ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ನ ಎಂಡ್ ವರ್ಡ್ ಸೆಕೆಂಡರಿ ಸಫಿಕ್ಸ್ ಅಂದ್ರೆ ಎಂಡ್ ವರ್ಡ್. ಆ ಎಂಡ್ ವರ್ಡ್ ಯಾವ್ದಾಗಿರುತ್ತೆ ಒಯಿಕ್ ಆಸಿಡ್. ಆ ಒಯಿಕ್ ಆಸಿಡ್ ಅನ್ನು ತೆಗೆದುಕೋತೀನಿ. That's why its IUPAC name 3-chloro-2-methyl hexanoic acid. Okay, na? In this way, okay, here that arrangement of suffixes as well as here two suffixes are there, primary suffix and secondary suffix. Primary suffix that will be represented based on the type of bond between the carbon atom, and secondary suffix will be represented based on the functional group that will be given highest order of priority. ಇದಿಷ್ಟರಲ್ಲಿ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ಗೆ ಹೈಯೆಸ್ಟ್ ಆರ್ಡರ್ ಆಫ್ ಪ್ರಿಯಾರಿಟಿಯನ್ನು ಕೊಟ್ಟಿದ್ದೀವಿ. ಹಾಗಾಗಿ ಆ ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್ ನ ಎಂಡ್ ವರ್ಡ್ ಅನ್ನ ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀವಿ ಒಯಿಕ್ ಆಸಿಡ್. ಅಂಡ್ ದಿಸ್ ಇಸ್ ದ ಐಯುಪಿಎಸಿ ನೊಮೆನ್ಕ್ಲೇಚರ್ ಆಫ್ ಎ ಮೋನೋಫಂಕ್ಷನಲ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್. ನೋಡಿ, ಇಲ್ಲಿ ಒಂದೇ ಒಂದು ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ಇತ್ತು. ಓನ್ಲಿ ಒನ್ ಫಂಕ್ಷನಲ್ ಗ್ರೂಪ್ ವಾಸ್ ದೇರ್, ಕಾರ್ಬಾಕ್ಸಿಲಿಕ್ ಆಸಿಡ್. ಹಾಗಾಗಿ ಇದು ಮೋನೋಫಂಕ್ಷನಲ್ ಆರ್ಗ್ಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ಅಂತ ಕರಿತೀವಿ. ಮೋನೋಫಂಕ್ಷನಲ್. ಪಾಲಿಫಂಕ್ಷನಲ್ಗೆ ಬೇರೆ ಇನ್ನೊಂದು ರೂಲ್ ಇದೆ, ಅದನ್ನು ಹೇಳ್ತೀನಿ. IUPAC nomenclature for monofunctional organic compounds. Like that, in the place of carboxylic acid, if SO3H group ಬಂದಿದ್ರೆ ಇಲ್ಲಿ ಆವಾಗ ಹೇಗಾಗುತ್ತೆ ಇದನ್ನ ಇಲ್ಲೇ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾ ಬರ್ತೀನಿ.